This is our demo video. First, I will open the propeller file. This propeller has 5 variables. Angle represents the angle of the wing. D represents the depth of the wing. W represents the width of the wing. L represents the length of the wing. And N represents the number of the wing. Our program changed these variable values to make random object and optimize the result by using the regression method. The user can open our program by clicking the Pikachu button on the right side. The first thing the user has to do is add variables. To add a variable, click the Add Variable button. To add the variable, the user has to type the variable name, its minimum value, its maximum value, and its type. After type it correctly, the user can add the variable to the program by clicking the Add Variable button. By repeating this step, user can add every variable that user want to vary by our program. Since the number of wing is integer, the user has to click the integer radio button. Now we will add constraint. Click Add Constraint button. The user can see the variable they add at the right top corner. To add constraint, the user has to type the constraint name and constraint equation. The constraint equation can be an equality equation or inequality equation. The user can load constraint and variable setting by clicking the Load button. As you see, the variables and constraints has been changed. The user can save and load the constraint and variables by the Save and Load button. After writing down the variables and constraint, the user can generate random object by clicking the Generate Random button. As you see, the variables has been changed. One of the constraints was having an 8 cm cube volume, and the constraint has been satisfied. If the user clicks the Generate Random button, our program generates a new random object. As you see, the constraint has been satisfied. To use the optimization feature, the user has to 3D print the objects and test them. The user can generate a number of random objects by setting up number of samples and clicking the button below. If the user clicks sample.sld part button, our program generates random SLD part file. And if the user clicks the sample.stl button, then our program generates random STL file. Our program is now generating 8 random objects with STL files. This is the result of Generate STL button. The first CSV files contain information about the variables, constraints, and samples. To use the optimization feature, the user has to fill in the result column. The user can use STL files to print, measure the result, and fill in the result column. For the optimization demo, we will use the data that our team has been working on. We generated 16 samples per generation, and this is the first generation. We printed the object and measured the float time. To do the optimization, click the optimization button and open the CSV file with the result. Then our program generates a regression function, find the optimal point, and change the variable range close to the optimal point. With this result, our team printed the second generation with the 16 samples. The user can optimize it with the second generation by clicking the optimization button and open the second generation result file. These are the propellers after 2 optimization process. The user can change the learning rate. Bigger learning rate change the variable range more dynamically. Thank you for watching this video.